Hello everyone, my name is Lakshman. In this video, I'm going to explain you about my internship task #6 iris dataset classification using decision tree classifier. So first of all, what is an iris? An iris is a flowering plant which bears some beautiful flowers. It has some, kind of 150 to 200 species. So in this task, I have been given a data set which consists of three species, namely Iris setosa, Iris versicolor, and Iris virginica. So in this task, I need to train a model in such a way that it classifies it into these three categories with as much as accuracy as possible. So for this data set, I have four attributes, namely sepal length, sepal width, petal length, and petal width. And the target variable obviously is the species. The species contains Iris setosa, Iris versicolor, and Iris virginica. So let's go into the code. So first I imported the necessary modules, namely pandas, numpy, seaborn, and sklearn. So now I'm gonna import the dataset, which is this iris.csv dataset. So after importing the dataset, I saw the first five values. The first five data entries, and I found that the first five columns are found to be a numeric data, while the last one, the species, is a string data. So while training a model, we need to make sure that all the data entries are numeric, not non-numeric. So later on, while training the model, I will make sure that this is numeric data, for which we can use the label encoder module. So after that, I use the info method to get some more insights about the attribute, and found that each attribute has some 150 entries, and they are non-null. And the data type, which we saw before, that the first four attributes data type is a float, which is a numeric, while the last one object is a non-numeric. So as I said before, we need to make sure that it is a non-numeric data. So, and then I use the describe attribute to get the statistical insights of our data set, and found, and you can get some generic statistical insights, like we got the mean, the standard deviation, minimum, and maximum. So after that, I made the count of the species, and found that Iris virginica, Iris setosa, Iris versicolor, each of them has 50 entries. So we can conclude that it is equally distributed. And after that, I made sure that each and every entry is in the data set, it does not have any missing values. So fortunately, our data set does not have any missing values, so we can go ahead and train our model. But before training our model, let's see the visualization of our data set. So using seaborn library, I made a pair plot which visualizes the bivariate relationship between each attributes, namely the sepal length, sepal width, petal length, and petal width. And while observing these plots and graph, we can see that one thing is quite obvious. The green colored one is quite very distinct and different from the rest of the rest of the plots. So the green color one is Iris setosa. So while training a model, we can conclude that this Iris setosa will be our training model will find it easier to classify this green color, which is Iris setosa, while it may find some difficulty in classification of the rest of the two species, which is Iris versicolor and Iris virginica. So from this plots and graphs, we got the inference that it would be easier to classify Iris setosa, while our model may find it a little bit difficult to classify the rest of the species. So let's go ahead and train our model. But before training our model, as I said before, we need to make sure that all the entries are numeric, but the species at column was not a numeric data. So using the label encoder, I made sure that each and every entry is a numeric data. So as you can see here, it has made the species, the Iris setosa species, to be 0, and Iris versicolor to be 1, and Iris virginica to be 2. So now that we made all our entries to be a numeric data, let's go ahead and train the model. So for this model, I have chosen 70% of the dataset to be a training data, and the rest 30% to be a testing data. So for this task, as I said before, we need to be using a decision tree classifier. So I imported the decision tree classifier, and then I made it fit inside my model, and then I ran my accuracy, and I got an accuracy score of 97.777, which is not the best, but it is quite good. So having our accuracy to be 97.7, let's do some visualization of our decision tree classifier graph algorithm. So the first one was petal length centimeter. Our decision tree graph algorithm has taken the petal length centimeter as an attribute for the classification. As you can see, it has for this attribute, it has categorized the entire iris setosa with just one attribute. As even you can see in the graph that the iris setosa is quite distinct and different from the rest of the species. So that's why in just one go, our dataset, our model was able to classify our dataset into iris setosa in just one go. While the rest, it needs some more attributes for classification. So that's why our decision tree classifier has taken some more attributes into consideration, like petal width, petal length, sepal width. So how this attributes are taken into consideration? These attributes are taken into consideration in such a way that the combined Gini factor is as low as possible. So that's why it has chosen the petal length as an attribute than the rest of the attributes like sepal length, sepal width, and petal width, because of the Gini factor, because of the low Gini factor. So as we go by, the best attribute is chosen so that the Gini factor is less. So as you go down, the Gini factor reduces, and at the leaf node, as for our dataset, the Gini factor is 0, which is quite good. And also our entropy is also decreasing as we go down. As you can see, the value is the samples is it's not random. It has a less entropy. So that's why this is quite a good algorithm to be taken into consideration. So this is my internship task. I hope it was insightful, and thank you for Sparks Foundation for this opportunity, and thanks everyone for watching, and have a nice day.